Hello, everyone, and welcome to episode 2 of Coffee with COSIMO. Today, we'll be talking about proof of stake and what is staking. My name is Jack Ward. I'm a principal with COSIMO Ventures and portfolio manager for our risk-managed diversified staking fund. With me today is Steve Flanagan from the Figment team. Steve, could you do an intro for us and a little bit about Figment?
Totally. Yeah, I'm Steve from Figment. So I lead our efforts on Ethereum staking. So all the engineering that goes into turning validators on and off, tracking what you earn, and then billing you using smart contracts. So Figment is a staking as a service provider. You show up with crypto, and then we get it staking and earn some staking rewards for you. We support a broad array of networks, but Ethereum is our main focus and something we're really excited about.
Great. Thanks, Steve. We're definitely very excited to have you on here today. Just to start this off, I'll do a little recap about last week's episode. All of these are recorded, so you can find it on our YouTube channel and socials if you missed it. But essentially, the first episode dived into what is blockchain on a very high level. And just to recap that, a blockchain is a secure, decentralized, and importantly, verifiable digital ledger that secures transactions and settles value across a global network of participating nodes. So what this does is it eliminates the need for central authorities and single points of failure. It ensures that all transactions are transparent, verifiable, and immutable, meaning they can't be changed. And then it's globally efficient, so you're able to settle value in transactions across the globe in a very efficient manner. And one important part that we discussed there is a global network of participating nodes. So Steve, what does it mean to participate in these blockchain networks?
Yeah, I mean, so there's the transactors that are actually adding data onto this blockchain, right? So that's if I'm sending money to you using a blockchain, we're putting that down as a record on the blockchain, right? That my account number 001 sent some amount of funds to your account 02. And then there's also the people that actually process those transactions and maintain this blockchain. So in a proof of work system, it looks like miners, which you guys probably touched on last week. And then in a proof of stake system, that's validators. And so they're applying any rules, such as making sure that I have the money that I claim to when I'm sending it to you. And maybe they're processing more complex data, like maybe they're handling a smart contract transaction where maybe I'm sending some money that is conditional on something, like it only sends it if it's sunny outside or something like that. So that's one of the exciting things that blockchains let us do, is that we can kind of get more complex transactions going that the validators will process for us.
Right. And this whole process and this validation and settlement, this is really what we're talking about is consensus. So this is everyone across the globe that's participating in this network saying, yes, I see this transaction, it happened, and nobody was acting maliciously in this process. So the first of these consensus mechanisms was proof of work, which is what Bitcoin uses for its consensus. And now we're transitioning to this next evolution, which is called proof of stake. And Steve, could you just go into a little bit about what proof of work is and how it differs from proof of stake and why we're transitioning to this more efficient model?
Totally. Yeah. So in proof of work, we have these miners who hear about the transactions and the data people want to put on the blockchain. They do some validations on it, and they spend a lot of computational power when they do so. And if they're lying, the network can notice that, right? There's this global network of people that notice it, and they can take away any rewards they would have earned. And they're left holding the bag for any electricity or computing power they spent. So it's not economically rational to lie about, your job when you're processing these transactions. Proof of stake accomplishes the same thing, but in a bit more of a clever way, in my opinion. It allows the people that process the transactions, the validators, to take some amount of the native asset. So in Ethereum, you're talking about ETH, and they put it down as collateral, right? And they allow the network to penalize them and take money from that collateral if they're found to be not playing by the rules. So that could be either like maliciously validating. You could be processing transactions that aren't actually valid, or vice versa, blocking transactions that are valid and censoring the network. Or it could even be things like performance related. Maybe you're just being a little slower than we would like in your validation. And we also could set up rules that penalize you for that. So it accomplishes these same goals of proof of work, right? It makes it economically rational to be a trustworthy, good validator, but it doesn't come with this whole system of spending electricity and computational power. So you remove a lot of these externalities that proof of work comes with. People have probably seen in the news that Bitcoin consumes a lot of power. Ethereum, which is on proof of stake, consumes 99.9% less power as a network. So there's less waste, and you still get all the same benefits of a decentralized blockchain.
Definitely. Yeah, there's some key points there that I just want to double check on here. So the whole concept of collateral and being aligned with the network. So that's really the game theory of these blockchain networks and how they make sure that everyone is acting as they should. So you brought up that, we brought up rewards, and we brought up slashing and other penalties for nefarious actors. Um, so what are these rewards, and what's the incentive to participate in these networks and contribute to the security of the blockchain?
Yeah, yeah. So when you validate, so either working with somebody like Figment or even running this software on your own, you're offering services to the network. You're saying, hey, tell me about transactions, and I will do either one of two things. I might get randomly selected to propose a block among all the validators in the world. And when that happens, that means that I'm the one who actually puts the data together and says, hey, here's all the transactions I heard about, and I'm going to put it on the blockchain. And everyone else, please double check my work, validate that it's a real block with good transactions. And then if so, it's in the permanent record of the blockchain forever. And so I get paid some rewards for that. The network, anyone who's in my block who's sending transactions, they'll give me a little bit of a fee. And the network might also give me some kind of inflationary reward, analogous to like the mining reward in Bitcoin. So there's that job that you get on random chance, right? You're one of the validators that's registered out there and you get selected to propose the block. There's the other source of your income, which is what we call consensus layer rewards at Figment, which is instead you're serving as that double checking committee where somebody proposed the block and you're looking at it and you're saying, yep, this is valid. And you're helping the entire network of all the validators arrive at a consensus. So we want some kind of majority or super majority of the validators to have signed off in a test and say, yep, that block is valid. And so when you look at those sources of income, right, because you get paid for being on that attestation committee and saying, yeah, this block is valid, with a little bit of inflationary reward. And so 80% of your income as a validator is usually going to come from those consensus layer rewards. And that's because you're getting it every block. It's smaller per block, but you're getting it all the time. Whereas the block proposal rewards, you usually get like a really juicy block reward. You might get like something as much as like a couple ETH, in what's called MEV. So it's kind of chance based on like what transactions you hear about and how, high fee they are. But it's also a low probability event. Most validators get to propose one block every 3 months per individual validator. So really, it's kind of nice in staking how you have this consistent source of rewards versus like mining, where you're spending the computational power trying to win the chance to get the block. And something that we think about at Figment a lot is the fact that there's also these slashing penalties, right? When you're doing this validation, you're put on something like the attestation committee, you might get penalized for just making it harder for consensus to arrive. Maybe you're sending conflicting information out to the rest of the network, and so those penalties do happen. And when you look at this business model of you can get 80% of your rewards from doing attestation every block, it really makes sense to prioritize safety over liveness. You actually want to avoid those penalties, even at the cost of potentially missing an attestation, missing out on a little bit of reward, because it's this kind of constant stream. So it's really an interesting game theory. It's pretty different from Bitcoin, but that's how we think about it.
Yeah, definitely very interesting. A lot of talk about blocks in there. And essentially what these blocks are is your transaction in the chain of blocks that is being agreed upon by these validators and by this decentralized network. So you're paying to the blockchain for your transaction to be settled and confirmed by all the participants. And there can be an immense value from that. Just the other day, we saw BlackRock do a $100 million USDC transfer on chain. And that was agreed upon from all the participants of the Ethereum network that transaction happened. And for that, people were issued rewards. So just to summarize everything we talked about, there is a network of all these nodes, computers being run by people that are coming to agreement on what's happening on the network. People are earning rewards called staking rewards for acting in alignment with the blockchain and for issuing those blocks in the blockchain. And then they're slashing and all these penalties that make sure that no one in the network is acting nefariously and trying to do something that they shouldn't be doing. So this is really the whole structure of blockchain networks and how they secure value in transactions on a global and efficient level. And a big distinction between proof of work, which Bitcoin started with, and proof of stake, which is Ethereum and many other blockchains, is that with proof of work, you're burning all this energy, spending all this computational computational power for the chance to earn the rewards. Whereas with proof of stake, you're actually taking the currency of the network, ETH in Ethereum's position, and you're collateralizing a node with that. And the more collateral that you have on the network, that can be slashed, so your ETH can be taken away, the higher probability that you'll act in alignment with the blockchain network. So that's really the whole consensus and mechanisms of the blockchain here. And we brought up another word in there, which is a validator. And do you just want to touch quickly on what a validator is, Steve?
Totally. So the way Ethereum designed its incentives was that they wanted every 32 ETH of collateral to correspond to one validator. And a validator is an actual computer somewhere running the software that processes transactions. And so if you have a lot of ETH to stake, you'll actually have many validators despite being one party. So you have to stake in these chunks of 32. And for each validator, they all have their own rewards and penalties. So if you have one computer instance out there somewhere that does maybe a thing called a double signing, which would be penalized, that 32 ETH validator will lose some ETH, but all your other validators are unaffected. And in the network's view, are actually like unrelated. These are all separate validators out there participating. And so, yeah, with Ethereum, something unique about it is that if you want to stake a lot of ETH at once, you have to kind of do some technical complexity to spin up all those computer instances and make sure they're all running properly all the time, which is a little more complicated than other networks like Solana, where you will actually just have one computer instance and it can have arbitrary amounts of capital on it. But there's trade-offs to both approaches, certainly.
Definitely. And another key concept that we touched in there is the efficiency that we get from these proof of stake networks. And we can actually tie this into the fundamentals of blockchain, which really isn't discussed enough. These things, this game theory and these structures are really built on some core fundamentals that can be put in really, traditional type terms. So those rewards that we're talking about, they're being paid out to the people securing the network. That's actually a cost to the network because they're issuing new currency to pay for that security. So that's what's known as a cost. And then the fees that people are paying to get their block in that chain of blocks, that ultimately boils down to revenue. So revenue is the fees that the blockchain takes in that actually accrue to the economic benefit of the token holders of that network. So we have people coming in paying for blocks, and Ethereum's, Ethereum is more general purpose. That might be for settling a real world asset tokenization transfer. It might be something in gaming. There's all sorts of use cases that these blockchains position themselves for. And really in the end, they're selling blocks. So you sell blocks, that's revenue. You issue tokens, that's network security, that's a cost. And then what we've actually seen is Ethereum is now the first profitable blockchain. So it's issuing less rewards for that security than it's taking in for fees. So what it does is it takes those fees, it pays out the validators, and then some of the rest of it is used to actually burn Ethereum. So this can be thought almost like a stock buyback program, where they're taking these tokens back and they're being destroyed. So while Bitcoin, it's all about monetary policy, it has a predictable issuance. Ethereum is actually deflationary. So since this merge from proof of work to proof of stake, Ethereum has actually removed, it's a negative 0.24% deflationary. So it's removing more supply than it has to issue to pay for its security, which is known as profitability. While at the same time, Bitcoin has inflation of about 1.7%. And, that's really positions ETH to be strong from a monetary and economic basis. And we can even take this down to an income statement. So for Q1 of 2024, Ethereum had just over 1 billion in revenue from people paying for this block space, paying for that consensus and settlement. Its costs in that time were around 665 million. So that's how much of the token value they had to issue out for that network security for all those validators to pay them. And the remaining portion there, this revenue minus cost, is the earnings. And that was about 370 million for Q1. So we have this global network securing these decentralized transactions with great settlement and efficiency, 99.9% more energy efficient than proof of work, and it's doing so in a profitable way. So this positions blockchain networks in general for really this next evolution, supporting, what we're calling the proof of stake powered digital economy, supporting use cases from real world asset tokenization to logistics to gaming and many more. And we're actually at the 11:15 time here. So we used that up very efficiently. I think we got everything done. Is there any final words you want to put out there, Steve?
Yeah, I mean, you were just touching on all the use cases for blockchain that are really going to drive a lot of this demand, right? The revenue that goes into the chain. And you mentioned earlier, BlackRock did $100 million transfer in USDC, and I was actually curious. They paid a $5 fee to do that, and so I'm just very excited. I think we'll continue to see a lot more of financial transactions move to this system, just because it's paying $5 to move 100 million in a decentralized, like trustless way is really exciting. So really excited to see more people use this and more volume get driven to Ethereum.
Definitely. And thanks for joining us today, Steve. We'll be on next Tuesday again, getting into topics. We talked about real world asset tokenization. Tokenization is the big movement that all these asset managers are kind of banking on for this new efficiency from these networks. So that's it for today. Thanks for joining us, Steve. And thanks for listening, everybody.
Thanks for having me.